before and after an observer program was put into place, the bycatch always goes up after observers show up on the boats. So this is definitely an issue in bycatch research. Now sometimes you actually can't get data from the fishery due to these different reasons. So in this case you can use something called fishery independent data to try and get an idea of what's going on in this fishing gear. And so in this case they'll run a research survey, and then with that research survey they'll use the same fishing gear in maybe a representative area or several areas or whatever. And then you look at what's caught in the fishing gear, and you can then infer that that might be what's going on in the actual fleet. So this is what we did with prawn traps. The Department of Fisheries and Oceans conducts a research survey with prawn traps. This research survey is not specifically to look at bycatch, it's actually to look at population parameters for shrimp and for the prawn recovery basically in the off-season, but they also record all their bycatch. So this was a great opportunity to use this data set for something other than it was originally intended for, to kind of get an idea of what's going on in the fishery. This is where the sampling took place. So it took place in Howe Sound, which along the coastline is right there. And every black dot on here is actually a place at which the fishing gear was set over the period at which the study took place. Then it went on from 1999 to 2008, and they sampled twice annually. It was very similar to the way they do commercial fishing, except that the strings were a little shorter. They used 20 traps instead of 50 traps. But it was done pretty much the same way. And then they recorded all the catch, and we analyzed the bycatch. And what we found was that overall, the rate of bycatch was actually quite low. 0.2 kilos of bycatch per kilo of spot prawns. Now compare this to the global average for shrimp trawling, which is how it's done mostly elsewhere, which was 5.7 kilos per kilo of target species. So by weight, this is pretty impressive. The most abundant species caught in these traps as bycatch were squat lobsters, which I don't think are a species of conservation concern, and giant Pacific octopus like this one here. The interesting thing about octopus is that they're actually allowed to keep that species in the fishery. So if you're totaling that up in terms of bycatch, you actually might not count that depending on how you do it. So it's a very selective fishing gear overall. In terms of rockfish, we found 264 rockfish in 856 strings. 79% of the strings deployed caught no rockfish at all. But the concerning fact is that the most commonly caught rockfish were quillbacks. This is concerning because COSEWIC has recently recommended that quillbacks be listed as a threatened species. There's many different population surveys and whatnot that have shown that there's this depletion in many different quillback populations. So if you're a prawn fisherman and you have this reputation for sustainability, you definitely don't want to be getting species that are being considered for threatened listing in your traps. To take a stab at trying to understand the demographics of what's being caught, we used the weights of the quillback of all the rockfish caught, and we calculated what the average size was of each, what the average size might have been of each species of rockfish caught in these traps. And we found that for quillbacks, the mean length was about 18.5 centimeters. The length at 15% maturity for the species is 29 centimeters, so these are all more than likely pre-reproductive individuals. Over time, the rockfish bycatch trend has gone down and then has increased since 2004. And so on the y-axis, what we have is the number of prawns per string on the right and the number of rockfish per string on the left. And basically what you should take away from this graph is there's been this increase in the rockfish bycatch, but that it doesn't necessarily link up with the prawn catch. The prawn catch has kind of been all over the place. To zoom in on the rockfish bycatch, what these figures translate into is per trap, in 1,000 traps they would catch 3 rockfish in 2004, and in 2008, in 1,000 traps they would catch 39 rockfish. So these numbers may sound very low to you. Why are we even worrying about this? But the prawn fishery, as I said, has about a little over 200 boats. And each boat has 300 to 500 prawn traps. And those traps are deployed every day for 60 days. So you end up getting a lot of fishing effort over the coast. So even a low number of rockfish per trap can end up being a large number overall. And that's the concern. Well, the question is, why has there been this increase? This is difficult to say, and we can't be certain out of this data set. The most likely thing you want to say when you look at catch per unit effort data is maybe there's simply more rockfish to be caught. And there is anecdotal support for that. There's a team at the Vancouver Aquarium that does these dive surveys in Howe Sound, and they noticed that in 2004 it seemed to be a very good year for rockfish survival, and there's a lot of recruitment. But, I mean, we can't be certain. Perhaps they just shifted their fishing effort a little bit. Perhaps there's some subtle change in the way they did their sampling that we can't see in this data set that might kind of negate that issue, and there's no other surveys that we can use to estimate the population density over this time. So all that we can really say here is that it might be because there's more rockfish, and it might not. But if you're a fishery manager and you see bycatch increasing in certain fishing gear, especially when it's a species that's being recommended for threatened listing, then this will raise red flags for whatever the reason of this increase is. So just in summary, to summarize that paper, how much bycatch occurs in prawn traps? Well, by weight, it's quite low, 0.2 kilos per kilo of target catch. Most rockfish caught were juvenile quillbacks, which are being recommended for threatened listing by Coast Seawick. They're not actually listed yet. And rockfish bycatch has increased since 2004 independently of prawn catch. So I'm going to move on now and talk about, this is the part that excites me, and this is developing a solution to this issue. When you're trying to reduce bycatch in any fishery, one of the first things you want to do is find the difference, think about the difference between your target species and your non-target species, and you figure out how to exploit those differences to make your fishing process more selective. The differences between target and non-target species could be morphological. Perhaps you're trying to catch shrimp and what you're trying not to catch is sea turtles. They're obviously very different in size and shape, so you can put on a selector grid or something and then you solve your problem. There could be a behavioral difference. When the trawl net's scraping along the bottom, perhaps your target species likes to swim up and your non-target species likes to swim down, so you can make your net selective so it only keeps the ones that go in the right direction. Or there could be a spatial or temporal difference. Maybe your target species lives over here and your non-target species lives over here, so you can just make sure that your fishing process is done in an area that will be more selective, or at a different time of year. Perhaps you only come out at certain times of year. Once you've done this research and you've figured out what the differences are, then you can make those modifications to the fishing process to make it more selective. So let's walk through this with rockfish and spot prawns. Right off the bat, we have a problem. Big prawns and small rockfish are very comparable in size, so you can't just make a smaller opening. In both, you can see if you look at the measuring tape here that they're actually quite comparable. Furthermore, rockfish and spot prawn habitat overlap strongly. So, as someone that was tasked with solving this problem, this is a little bit disheartening because it's not a simple fix right off the bat. So I realized at this point that I needed to go collect more data. So I went out to sea with some fishermen, and this was actually quite a difficult process. I had to go and meet with a lot of these guys many times and convince them that I wasn't there to shut down their fishery. I wasn't there to misreport things. I just wanted to get information so that I'd be better equipped to solve this problem. So opportunistically, I basically approached different fishermen, and I ended up getting to go on boats in the Howe Sound and nearby areas, right here by Vancouver, up in the northern Gulf region, and over in Nootka Sound. So three very distinct geographical areas. And when I was on the boats, for each rockfish caught, I recorded the species. I measured the dimensions, so the length, body depth and width and that sort of thing, fin length. And whatever else I could, so like the depth of capture, which I'd get from their depth sounder, and also qualitative data about the fish condition. I also looked at other fish bycatch, but I'm not really going to talk about that today. And this video just shows you what it's like to be with the DFO observer group. So this is when I was in Nootka. They speed along on these Zodiacs and they pull up to the commercial fishing boats and they board them, and that's when they do the observation. This is what it looks like when you're on the boat and they're pulling up the fishing gear. So you can see there's a big hydraulic winch and it pulls up the whole string, and then they unclip the trap, drop it into the sorting tray, and he just got rid of his bycatch. So that's how fast this can happen. This is how gear is set. So we're now going along and there's a string going out the back of the boat, and he's just waiting for, there's little knots in the string that indicate how far apart you should space each of the traps. So he's just going on and he's clipping the traps one at a time. What you see here is this is actually a whole stack of 50 prawn traps. So it does take up a lot of space on the boat when they're all on there. Okay, moving on. I got the opportunity to look at a total of 3,750 prawn traps. And in those traps, they caught a total of 50 rockfish. And what we have here is just some data about the dimensions, and all that you need to take away from this is that there's a large difference between the smallest rockfish that I encountered and the biggest one. To visualize this, I modeled it in 3D, and basically each of these cylinders represents a rockfish, so you have to use your imagination. This is to scale, and basically it's a cylinder that has the same length dimension and width and depth dimensions that I observed in the fishery. And over here, for comparison, is the largest spot prawn that I saw when I was out there. And so what you should notice immediately is that this one looks very similar to this one. The mean size of rockfish is very similar to the largest spot prawn. And this is the standard ring size, so a 3-inch ring size, just for some reference. To visualize this another way, we'll just do a quick fly around so you can kind of